Okay, guys, we're going to go ahead and practice balancing a few equations using the rules that we talked about in the notes. So just to refresh your memory from what we learned about before, to balance equations, the goal is to get equal numbers of every single atom on both sides of the equation. You need, if you have 5 carbons on the reactants, you need 5 carbons on the product side. The only way that we can do this is by altering the coefficients. So we can put a coefficient in front of a chemical formula, but we can't change the formula for the chemical formula. So what that means is I can't change any of the subscripts. But this needs to represent the law of conservation of mass. So we need to see what ratio these reactants are reacting in, and what ratio of products are formed as a result. So really it's just coefficients. Some other helpful hints: balance metals first, then we balance nonmetals, then we balance oxygen and hydrogen last. So applying those bits of information, and this is a lot of trial and error. I suggest using a pencil when you do this, because you may find that you think a coefficient works, but then it ends up not working. So a lot of times you have to go back and erase and start over again. So use a pencil, try to be patient, and after a while you'll get the hang of it. All right, so let's look at the first one. We have 3 carbons on the reactant side. So I only have 1 carbon on the product side. I'm going to put a 3 in front of here to now represent that I have 3 carbons. So when you're dealing with these coefficients, what this is actually saying is that I have 3 CO2 molecules. I have 3 carbons. So you always take the coefficient and multiply it by the subscript. So at this point I have 3 carbons, and I have 3 times 2, so I have 6 oxygens by putting this 3 in front of the CO2. Because what it really represents is that I have a CO2, a CO2, and a CO2. So if I count them up again, 3 carbons, 6 oxygens. So the coefficient needs to be multiplied by the subscripts when you're taking account of these atoms. So I put a 3 in front of here. Now my carbons are balanced. Now I'm going to move on to hydrogen. I have 8 hydrogen over here. So if I put a 4 in front of here, 4 times 2 is 8. So the subscript 2, 4 times 2 is 8. So I have 8 hydrogens on the product side now. Now I just need to take account of my oxygens. Over here I have 3 times 2, 6 oxygens. I have 4 times 1, 4 more oxygens. So I have a total of 10 oxygen on the product side. If I want to get 10 oxygen over here, 5 times 2 is 10. So now I take account again. I have 3 carbon over here, 3 carbon over here. I have 8 hydrogen on the reactant side. I have 8 hydrogen on the product side. I have 10 oxygen. I have 6 plus 4 more. I have 10 oxygen on the product side. So if there's one that's blank, you just put a 1 in front of there. And guys, keep in mind too, you might look at this and go, wait, but there's oxygen here and here. Well, all of these oxygens are on the product side. So we have to count up the total number of oxygen, even if they're not in the same compound. That's what happens during chemical reactions. Atoms rearrange themselves, they hook up with other atoms, and they may not be together in the same chemical formula, but they're still there. They're still on the product side. So we have to account for all of them. So that is the answer to number 1. Now, number 2, again, we start out, I look at aluminum. I have 1 aluminum on each side, so I go on to the next element. I have 3 iron over here and only 1 over here. So I'm going to change this to a 3. And then I look at nitrogen. I have 2 over here, and I only have 1 nitrogen over here. So I have to put a 2 there. Now what that did, now that I put the 2 in front of here, that also affects the aluminum. So now I have 2 aluminum on the product side, so I have to put a 2 over here. And now I have equal numbers of each atom. I have 2 aluminum over here. I have 3 iron over here. I have 2 aluminum over here, 3 iron over here, and I have 2 nitrogen and 2 nitrogen. This coefficient makes it 2. So it is a 2, 1, 2, 3. That is what the actual balanced equation should look like. Okay, next one. This one's pretty simple. We have one sodium on each side, but we have two chlorines and only one on the product side. So I'm going to put a 2 there, and then that gives me 2 sodium. So I need to put a 2 here and then a 1 here, and that balances the equation. I have 2 sodium on each side, 2 chlorines on each side. Equation is balanced. All right, number 4. On number 4, we have 2 hydrogen and 2 hydrogen balanced, but we have 2 oxygen on the reactant side, and we have a total of 1, 2, 3 oxygen on the product side. The reactant side, it doesn't matter what coefficient I put here, it's going to give me an even number of oxygens. So I need to make sure that I have an even number of oxygens over here on the product side. So I need to keep that in mind when I'm putting coefficients in front of there. So what I'm going to do is give me an even number of oxygens on the product side by putting a 2 there. Now I have 2 oxygen plus 2 more. I have a total of 4 oxygen on the product side, and I also have a total of 4 hydrogen on the product side. Now all I need to do is go and put a 2 in front of here, which gives me 4 hydrogen and 4 oxygen, so I'm balanced. I have equal numbers on both sides, and I just make that a 1. Next one, these can be a little bit tricky. They are combustion reactions. We know it's a combustion reaction because we have some kind of sugar or hydrocarbon reacting with oxygen, producing H2O, water, and carbon dioxide. So we're going to skip over that one for right now and go back to it in a little bit after we've practiced doing polyatomic ions. So let's go down to one that has an actual polyatomic ion. And that would be number 8. Um, the the thing with polyatomic ions, as long as they remain intact, you can balance them as one unit. And it's actually going to save you a lot of time by doing that. You don't have to count up all the individual atoms. You can balance them as one thing. So what I mean by that is over here I have an NH4, and I also have NH4 over here. Over here I have a PO4, that's the phosphate. And I also have a phosphate over here. Over here I have a nitrate, and I also have a nitrate over here. So because those things did not break up during the process of the chemical reaction, we can balance them as one unit instead of trying to keep track of all those oxygens and nitrogens and everything. So what this 3 outside of this parentheses means is that I have 3 NH4s in this chemical formula. So I have 3 of that entire thing. So we can keep that in mind as we're going through and balancing this. So what I'm going to do, I'm going to start off by balancing the lead first because I'm going to follow my rules where you should balance the metals first before you start to balance the nonmetals. So here I have 3 lead on the product side and I only have 1 over here. So I'm going to go ahead and put a 3 in front of that. Now what that does is it changes the number of nitrates that I have on my reactant side. So I have 3 times 4 nitrates. I have a total of 12 nitrates now because you have to multiply the coefficient by the subscript. All right, so I have 12 of the NO3s now. So I'm going to go ahead and put a 12 over here to represent that I have 12 NO3s on the product side. Well, when I put this 12 here, that also affected the ammonia. So now I have 12 ammonias. And on this side, I only have 3, but that's easy to take care of. 4 times 3 is 12. So now I have 12 ammonias on this side. Well, by putting this 4 in front of this, I've also affected the quantity of phosphate that I have. So now I have 4 phosphate on the reactant side, and I come over here and look, oh, I have 4 phosphate on the product side. So this is a balanced equation now. I put a 1 here. So to review, I have 4 times 3, 12 NH4s. I have 4 PO4s. I have 3 leads, and I have 12 nitrates. Over here, I have 3 lead, I have 4 PO4s, I have 12 NH4, and I have 12 nitrates. So everything is balanced at this point. My coefficients are 4, 3, 1, 12. So it's 4, 3, 1, 12. this is what the balanced equation would look like. Another thing that you should pay attention to when you're balancing equations is making sure that the coefficients are represented in the lowest whole number ratio. If they could be reduced, you need to reduce them, but it has to be every single coefficient needs to be reduced. On this one, you can't reduce the coefficients any further, so we have the lowest whole number ratio possible. All right, let's go on to number 9. Number 9, again, let's balance metals first. So I have lithium right here. I have 2 of them, so I'm going to put a 2 over here to represent 2 lithium on the product side. Then I'm going to go on to boron. So I'm going to start in with my non-metals now. I have 1 boron over here and I have 2 over here, so I'm going to put a 2 right there, which changes the number of fluorines that I have. 2 times 3 is 6 fluorines. So remember, we multiply the coefficient by the subscript. So I have 6 total fluorines on this side. Now this is going to be a problem because I already put the coefficient of 2 over here. So this is why I said use a pencil. I'm going to erase that and I'm going to go ahead and put a 6 because now my fluorines will be balanced, which just messed up my lithium. Now I have 6 lithium on the product side and I need to get 6 lithium on the reactant side. Easy to fix. I just put a 3 there. 3 times 2 is 6. Now I have 6 lithiums. Now let's see what else we have. I also, now by putting this 3 here, now I have 3 of these SO3s. Well, over here, I already have 3 SO3s, so that's balanced. Now let's just double check, take a count. 2 boron, I have 6 fluorine, I have 6 lithium, and I have 3 of the SO3s. Product side, I have 2 boron, I have 3 sulfite, 3 SO3s, and I have 6 lithium, and I have 6 fluorine. Equal numbers on both sides, so my coefficients are 2, 3, 1, and 6. All right, last one I'm going to do is number 11. And again, I'm going to start out by balancing the metals, which is calcium. And I have 3 calcium over here, so I'm going to put a 3 right here, which now affects my carbonate as well. So I'm going to look at the product side. I do have a carbonate over here, so I'm going to go ahead and put the coefficient 3 in front of here to balance my carbonates. Because remember, the coefficient goes for everything in the entire chemical formula until you hit either an arrow or a plus sign. Now I've balanced my calcium, my carbonates. Now I'm going to look at phosphate, PO4, and I also have a PO4 over here. I actually have 2 of them. So I'm going to go ahead and put a 2 here to balance my phosphates. Now let's take account of the hydrogens on the reactant side. I have 6 hydrogen over here, and I have 6 hydrogen over here. So everything is balanced. I have 3 calcium. I'm going to write this right here. I have 3 carbonates. I have 6 hydrogen, and I have 2 phosphates. That's on my reactant side. Product side, again, I have 3 calcium. I have 2 phosphate. I have 6 hydrogen, and I have 3 carbonates. So we are finished. It is balanced, and we're good to go.